plus 1/2 root p to the fourth. So at this point, what is our n? Our n equals 4, so we need to get down to the n equals 4 row. We start at n equals 0, 1, n equals 1, 1, 1, n equals 2, 1, 2, 1, n equals 3, 1, 3, 3, 1, n equals 4. Finally, the row that we actually care about, 1, 4, 6. 3 plus 3 is 6. 3 plus 1, 4, and 1. Great. So that's the row that we will actually wind up using because our n equals 4. So that we don't wind up getting cramped, I'm not going to wind up writing here. I'm going to wind up doing the expansion down here. So our first thing will be sum blank times, well, what's our a? That's the good thing to identify. Root 3u squared is what our a is equal to, right? A plus b to the sum n. So in this case, the a is all of root 3u squared, and the b is all of 1/2 root p. Okay, so we're now ready to do this. So the first one will be root 3u squared to the n equals 4, and then 1/2 root p to the 0, so I won't even write that one there, plus blank root 3u squared to the 3 times 1/2 root p to the 1, plus blank root 3u squared squared times 1/2 root p squared, plus blank, let me break that down to the next line just so we can have plenty of room, plus blank root 3u squared to the 1 times 1/2 root p to the 3, plus blank root 3u squared times 1/2, to the 0, so we can just disappear that entire thing, times 1/2 root p all to the 4. Great. So I want you to notice here, don't get confused by the fact that it's u squared or root p. The fact that there's exponents on stuff inside of the binomial doesn't matter. We still do this part where the one exponent steps down with each step, and the other exponent, the one that starts at 0, steps up with each step of the terms that we work through. Great. At this point, we can now plug in our binomial coefficients. So a 1 for our first blank, a 4 for the next blank, a 6 for the next blank, a 4 for the next blank, and a 1 for our final blank. At this point, we can now finally actually simplify this guy. Well, let's do it in 2 steps. So 1, we'll just have that disappear. Root 3u squared to the 4th. Well, root 3 squared is 3, so root 3 to the 4th is 3 squared. So root 3 to the 4th is the same thing as 9. U squared to the 4th is u to the 8th. Plus 4 times root 3 cubed is going to be 3 root 3. U squared cubed is u to the 6th. 1/2 root p to the 1 is just 1/2 root p. Plus 6 root 3 squared, root 3 u squared squared. Root 3 squared is 3. U squared squared is u to the 4th. Times 1/2 root p squared will be 1 over 4, right? 1/2 squared is 1/2 times 1/2, so 1 over 4. Root p squared is p. Break the line once again. Plus, next is 4 root 3 u squared to the 1. Well, that just stays as root 3 u squared times 1/2 root p cubed. 1/2 to the 3 is 1 over 8. Times root p cubed is p root p. And then finally, plus 1 times 1/2 root p to the 4th is going to be 1 over 16. Root p to the 4th is going to come out as p squared. Great. Now we can simplify this whole thing, do the last of the simplification. So 9u to the 8 plus 4 times 3 root 3 times 1/2. So 1/2 cancels the 4 down to a 2. We're left with 6 root 3 u to the 6th root p, plus we've got 1/4 here, so this will become 1/2. This will become 3. 6 times 1/4 becomes 3 times 1/2. So 3 times 3 is 9, divided by 2. We've got 9 over 2 is the coefficient there. U to the 4th p, plus 4 root 3 times 4 root 3 u squared, 1/8 p root p. Hoi, a lot of things. So 1/8, that'll cancel the 2 when it knocks out this 4. And so we've got root 3 over 2 u squared p root p, and finally our last term, 1/16 p squared. And there is the full expansion. It's about as difficult as any expansion of the Pascal's triangle will wind up being, but still notice how much faster that wound up making it than if we had tried to do this whole thing by hand of doing root 3u squared plus 1/2 root p times root 3u squared plus 1/2 root p times root 3u squared plus 1/2 root p times root 3u squared plus 1/2 root p. We'd still be working through it, and we'd still have a lot more to go. So it makes things faster. We have to be careful and make sure that there's a couple things we have to pay attention to. We really have to make sure that our n, the row that we're using the Pascal's triangle, matches to the exponent we're raising to. We have to pay attention to what is our whole A, what is our whole B, right? It has to be the entire term, not just the U, not just the P, but the entire term of something plus something. And if it's a minus, it has to be something plus a negative something. And then we set it up with this step down, step up pattern, the blanks, and then we can just slot everything in. If it's a simpler problem, you might be able to do it without having to take such careful steps. But if it's a big, complicated problem, I really recommend do the careful steps. It'll make it easy to not make a mistake and make the problem just a slow cakewalk. All right, cool. So that finishes up for the examples. If you're heading out now, we'll see you at Educator.com later. Bye.